Welcome back to the channel. This is the Earth Science Classroom. This video is looking at depositional environments in regards to sedimentary rock formation and looking at how these environments form, different locations and their definitions. This is the Earth Science Classroom. Sedimentary rocks are one of the three main rock types. Now, sedimentary rocks form from the accumulation of what's called sediments or clasts. Now, these rocks can form in different ways and there are different classifications. There is a clastic sedimentary rock based on the different size of sediments that are used to form a certain rock, and there's also chemical sedimentary rocks that form through precipitate and evaporites and minerals left after the water has been moved on or evaporated. And we have also biochemical sedimentary rocks that form from organic life and their shells. And the shells contain minerals, and those minerals accumulate to form certain sedimentary rocks. So of the main classifications, these rocks form from certain sediments accumulating in a certain environment over a certain time. And this environment is called the depositional environment. So where these sediments or these materials that form sedimentary rock have been deposited, been dropped by an erosional agent like water or wind, or let's say gravity, like a mass wasting or mass movement like a alpine glacier, for example. And these environments create the rock. They create the sedimentary rock from which we can assess and reconstruct what happened and what that environment was like. For example, what material, what sediment was used to form the rock. We can work back and see what kind of environment would lay down that kind of sediment. So the understanding of a depositional environment is key to understanding what happened in that location to form that particular sedimentary rock. And these environments come in three types. There's terrestrial environments, where the sediments lay down on the surface of the earth above sea level. There is coastal, that in between, where you might have some terrestrial and some aquatic or marine, but you have that flux between dry and saturated environments. So the last one is marine, which is going to be water-based, most likely ocean or sea, or perhaps a very large lake. So as a summary, there are three depositional environments that we covered in this video. There's terrestrial, coastal, and marine. Now, coastal is also called marginal marine. So these environments change and have certain characteristics and form certain sedimentary rocks. For example, terrestrial includes alpine glaciers, alluvial fans, rivers both meandering and braided, any kind of lacustrine environments like lakes and ponds, swamps, marshes, wetlands, and any kind of desert environments. And these environments are going to form specific sedimentary rocks. For example, deserts will form a lot of sandstone. Conglomerate comes from glacial till and alpine glaciers. Breccia can also form this way. Lakes and swamps can form shale and coal. And this is based on the energy levels of the erosional agent that is transporting and then depositing such sediments. Then we have the coastal or marginal marine environment, which is that in-between flux between the dry and the wet, and a lot of the beach environments where you have the rivers flowing into the oceans via any kind of estuary or sound or inlet, which creates these different and unique environments. For example, you might have a river delta, a tidal flat. You might also have a near shore reef, a beach, lagoon, and these environments create certain kinds of sedimentary rocks. For example, a beach might have a lot of sandstone, a reef, limestone, a lagoon, you might get some shale, tidal flat, you might get some mudstone. And then we can get into the deeper parts of the ocean and the marine environments, and this would be your continental shelf, the slope and the rise, the submarine fan, and abyssal plains. So The sedimentary rocks that are formed in this deep marine environments would be the shale and siltstone and limestone on any kind of continental slope. The abyssal plains could form chert, which is the SiO2 fine-grained sedimentary rock. So anywhere around the world on the Earth's crust, on the surface, be it under the ocean, be it on a coastline or on a continent, you can find a certain sedimentary rock. And from that rock, and from the characteristics, and from the different facies that the rock has, the thickness, the fossils, the grain size, the sorting, the element composition and mineral composition, and the color, we can establish what kind of depositional environment this rock was formed in, and the time through radiometric dating or index fossils. We can figure out a lot of information from this rock about the environment in which it was formed, and the climate, the wind or the water, the flow of the water, the depth of the water, even the temperature of the water, the location, and also the changes that have happened since that rock was formed, whether it be tectonic or orogeny or sea level rise or fall, because the other rocks around it, above and below, tell a different story that would add up, and scientists can use this to establish a very detailed paleo-environment from millions or even billions of years ago when that rock was formed. So to understand these environments and the corresponding rocks that form is very important, because we use uniformitarianism as that base principle that what happened in the past also happens the same in the present. So these rocks are forming now form the same way as the past. So we're using this principle, this law, and applying it to these environments to understand what happened in the past at a certain location. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth science, please check out my channel.